String theory is one of the most intriguing subjects in all of physics. Yet most people have never heard of it since it is a relatively new field of study, and the concepts it describes seem really complex and out of touch with what we humans find normal. Or at least that is how it seems. So what is it exactly? First we shall define string theory. String theory is the unified field theory that explains everything in the cosmos and their interactions within it. From the smallest things to the very largest of things.
The theory is mainly based off of mathematical models created by Dr. Veneziano, and it is famously advocated by Dr. Michio Kaku and Dr. Greene.
Now, in order to work with string theory, we must go over two postulates or ideas that are the structural basis for all things in this theory. For the first postulate, let's stand up and take out a deck of cards. This deck will represent an atom in free space and will serve as a model. In the quantum world, the atom is composed of multiple subatomic particles that give the atom its many properties and such. If we break down the atom into its components, removing the electrons, we find that the nucleus of the atom is made up of neutrons and protons. We can go further by breaking the protons and neutrons into their components, and we find that they are made up of quarks. But now we have a problem. We've been able to figure out the components of the atom all the way down to its quarks using quantum mechanics, but we can't go further. Why? Quantum mechanics only describes the subatomic components of a particle all the way down to the elementary particles. Particles that cannot be broken down into other components. When one uses quantum mechanics to go beyond these elementary particles, the entire structure of quantum theory breaks down. That is, if you don't use string theory. String theory explains that each fundamental particle we all know and love is composed of a small strand of energy vibrating in a 10-dimensional hyperspace, defined simply as a string. These strings vibrate at different frequencies, like the strings on a cello, and like the strings on a cello, their frequency can change. This explains why there are so many different elementary particles in this universe. The theory also goes further still, describing what might be beyond the string, predicting extremely small dimensions that we humans cannot perceive. And even other particles have been predicted for the standard model of particles, such as the graviton, which is believed to be the carrier of gravity. Thus, that is the first postulate, the idea that goes beyond not just quantum theory and the standard model, but also the string itself. For the second postulate, let's stand up and blow a balloon. This balloon will represent our expanding universe with all the air inside it representing all that exists. Normally one would use general relativity to describe the very large things in existence, such as the observable universe itself. Alas, this theory is limited to the instant our universe was created, the Big Bang, and it cannot explain anything beyond that, meaning Einstein's theory can only take us so far before... String theory, on the other hand, extends the world of the really big stuff before the Big Bang, before Genesis itself. But how? String theory predicts a multiverse, an entire collection of universes that move about each other. These universes are all different from one another, having their own set of laws and are separated from one another by membranes, or branes for short. Every now and then, universes collide into each other to form a new universe, and every now and then a universe will split to form two new universes. And the combining and fissioning of these universes may very well be the cause of the Big Bang. And that is the second postulate, the idea that goes beyond general relativity and even beyond Genesis itself.
Why is this necessary? Can't we just put quantum theory and the theory of relativity together and we'll have our unified field theory of everything? Well, yes and no.
Yes, combining the two together would provide a theory that explains everything, and the desired result would be quantum gravity, which was an early attempt to explain gravity at the quantum level. But when combined, they fall apart, since one is stable and the other is horribly unstable. So no. Even the great Albert Einstein was stumped by this problem. What string theory does, though, is it creates a framework that bridges the two theories together, combining them indirectly. And the two postulates for string theory was a result of bridging the two fields together. That in itself is a mathematical beauty. In conclusion, string theory is not just a theory of everything, but also given that it goes beyond the really small and beyond the really big. It is the theory that goes beyond everything. But remember, it's only a theory.